Very big body.
Oh, nice.
Yes, look at that bad boy.
This is a raw image, so this is not even like, I mean, this is just directly from the telescope right now.
You're looking at a piece of what would have become a planet in another star system.
A strange visitor has just crossed our solar system. The James Webb Space Telescope managed to capture its first real image, and what appeared has shaken the entire scientific community. This is not a familiar comet, but a wanderer from the deep reaches of the Milky Way, carrying traces that do not belong to Earth. Inside, scientists discovered compounds never seen before, some that may even be the missing pieces that sparked life itself. But this secret is only part of the story. If 3I/Atlas is truly a messenger from another world, what message will it leave us? And could it change the way we understand our own origins? Astronomers knew something extraordinary was happening the moment they tracked a body cutting across the solar system on a hyperbolic path. Unlike comets and asteroids that loop around the sun in predictable orbits, this one was set to pass through only once before vanishing forever into interstellar space. It would not return in 100 years or even 1,000,000 years. This was a visitor that offered humanity a single chance to capture its image and decode its story. The James Webb Space Telescope, orbiting nearly 1,000,000 miles from Earth, became the tool that turned this fleeting moment into a permanent record. With its 6.5-meter mirror and infrared vision, Webb was ready to catch what no ground-based telescope could. When its sensors locked onto the strange object, it froze time in a way no human eye ever could, transforming a temporary blur into sharp, historic data. This was not just another observation, it was a once-in-a-lifetime event, the kind of discovery that makes scientists speak in hushed voices and the public feel they are witnessing a secret of the universe revealed for the very first time. The object was named 3I/Atlas. The 3 marks it as only the third interstellar object ever recorded, following the controversial Oumuamua in 2017 and the comet Borisov in 2019. I stands for interstellar, and Atlas honors the telescope system in Chile that first spotted it. Already the name carries weight, a rare category of cosmic wanderers that appear without warning and disappear before questions can be fully answered. For perspective, the closest this traveler will ever come to Earth is 1.8 astronomical units, about 170 million miles away. That distance sounds vast, but in cosmic terms it is just enough for Webb to aim its instruments with stunning clarity. What makes 3I/Atlas so compelling is not only its rarity, but also the sense of paradox it brings. How can something born around a distant star, billions of years ago, suddenly flash across our skies for just a brief moment? Its orbit confirms beyond doubt that it does not belong here. It is not tied to the sun, not a child of our planets, but a stranger moving at incredible speed through the neighborhood of our solar system. That realization alone is powerful. It proves the galaxy is not silent, but alive with moving fragments that carry the history of other worlds. Every detail Webb captures matters because there will be no second chance. The telescope's success means humanity now holds a true portrait of an interstellar visitor, something that generations before us could only imagine. The chance that such a large body would intersect with our tiny patch of space while a billion-dollar telescope happened to be in perfect position is almost unbelievable. It feels like fate and preparation collided, delivering an image that forces us to rethink our place in the cosmos. The story of 3I/Atlas begins as a tale of rarity and timing, a cosmic event that will never repeat. But the bigger question is how we moved from a faint streak of light on July 1st, 2025, to the confirmation that this was no ordinary comet at all. So how did scientists uncover the truth behind that mysterious streak in the sky, and how did it earn its place as the third recognized interstellar traveler? The story of 3I/Atlas did not begin with a sharp image from the Webb telescope, but with something far more humble. On July 1, 2025, the Atlas survey system in Chile flagged a faint streak of light moving strangely against the background of stars. At first it looked like any other detection, the kind that observatories log by the thousands, but the motion did not match the familiar rhythm of comets or asteroids bound to the sun. It hinted at something unusual, and the discovery was quickly passed to the Minor Planet Center for deeper review. When astronomers pulled older data from June 14, 2025, they realized the object had already been hiding in plain sight. Those pre-discovery observations, gathered from different Atlas telescopes and the Zwicky Transient Facility in California, helped build a clearer picture of its path. Step by step, the evidence grew stronger. The orbit was not curved back toward the sun like a boomerang. Instead, it stretched into open space, the mathematical signature of a hyperbolic trajectory. That meant one thing only: the object had not been born in our solar system. Naming followed the rules of astronomy, but carried a sense of drama. The number 3 marked it as only the third interstellar object ever found, while the I stood for interstellar. The final part, Atlas, honored the survey team that first caught sight of it. In just a few days, the faint smudge became a named traveler, carrying an identity that placed it in the rarest category of cosmic visitors. Unlike Oumuamua, which was first met with confusion, or Borisov, which looked like a textbook comet, Atlas entered the stage with enough data to confirm its alien origin almost immediately. The scale of its journey also became clear. At closest approach to Earth, it would be 1.8 astronomical units away, about 170 million miles. This distance posed no danger but was close enough to give telescopes around the world a chance to observe. More importantly, it gave the James Webb Space Telescope time to prepare for a detailed look. The discovery had moved quickly from suspicion to confirmation, and now scientists were racing the clock before the object disappeared behind the glare of the sun. For the public, the discovery was both thrilling and unsettling. Headlines announced the arrival of a new interstellar comet, and people wanted to know what it meant. Why was it here, and what secrets could it hold? Astronomers explained that its presence proved the galaxy was full of wandering bodies, fragments cast out of distant star systems. This was not a chance illusion, but part of a much larger story about how planets, stars, and debris interact on a galactic scale. In many ways, Atlas was evidence that our solar system is connected to a wider web of movement and exchange, even if we rarely notice it. The chain of discovery, from a faint streak on a survey image to confirmation of an interstellar guest, shows how modern astronomy works best: patient, precise, and ready to act when the rarest opportunities appear. But spotting Atlas was only the beginning. The real turning point came when Webb pulled back the cosmic curtain and showed its face in full detail. So what exactly did the telescope reveal when it focused on this visitor? And how did the image change the story forever? The moment the James Webb Space Telescope focused on 3I/Atlas, the story shifted from speculation to revelation. Ground-based observatories had only seen a dim streak against the starfield, but Webb's massive mirror and infrared sensors cut through cosmic haze to reveal a sharp portrait. For the first time, humanity was looking straight at the face of a visitor from another star system. The picture showed a surface that was far from simple. Bright reflective patches hinted at frozen ices, sparkling like mirrors under sunlight. These regions suggested that parts of Atlas were actively releasing gas as they warmed, behaving in ways similar to comets we know. At the same time, deep scars and irregular markings carved across its body spoke of violent impacts and fractures. It was not smooth, but rugged, a relic scarred by countless collisions during its long journey. This combination made Atlas appear like a hybrid, carrying both comet-like ice and asteroid-like rock in one body. Adding to the mystery was the faint but undeniable halo surrounding it. This coma, made of dust and gas, proved that the object was not dead rock, but alive with activity. Unlike the dramatic tales of giant comets, its halo was subtle, almost fragile, but it confirmed that Atlas had preserved volatile material for billions of years before releasing it in our solar system. It was proof that even after traveling through interstellar cold, the object still carried its original ingredients. The significance of this capture cannot be overstated. Earlier interstellar visitors had left astronomers frustrated. Oumuamua's strange shape offered only blurry hints, and Borisov's trail could not be fully decoded with limited instruments. Atlas, however, appeared in full detail. Webb's position beyond Earth's atmosphere meant there was no distortion, no interference. Instead of a passing blur, scientists now had a clear body to measure, analyze, and compare. This was the turning point where interstellar research moved from theory into tangible observation. For the public, the image had an almost emotional impact. To see Atlas glowing against a tapestry of stars was to realize the galaxy is not distant, but immediate, a place where fragments of other systems can cross paths with ours. It was a reminder that the solar system is not isolated, but part of a restless and connected Milky Way. For scientists, every pixel represented a victory, not only of technology, but of timing, because this guest would never return. What Webb revealed was only the beginning, and the real secrets would come when its instruments broke down the light into chemical fingerprints. So what strange elements did astronomers find hidden within Atlas, and could they tell us something about the very origins of life itself? When the James Webb Space Telescope turned its spectrograph toward 3I/Atlas, the real secrets began to emerge. By splitting the faint light into colored bands, Webb revealed a chemical fingerprint unlike anything seen in comets from our own solar system. It was as if the object carried a coded message written in molecules waiting to be read. The first surprise was the presence of common ingredients such as water ice and carbon monoxide. These compounds showed that Atlas had preserved volatile materials during its long journey through deep space, yet the ratios were far from ordinary. Astronomers found the highest level of carbon dioxide compared to water ever measured in a comet. This imbalance suggested Atlas may have formed near the so-called carbon dioxide ice line, a zone in a young star system where frozen carbon dioxide can survive, but water ice is less stable. Such conditions point to an origin very different from that of our solar system's comets. Even more stunning were the exotic organic molecules detected in the data. Some matched patterns rarely seen before, while others were completely new to science. These complex carbon chains may have developed under intense radiation or in cold clouds rich in interstellar dust. For astrobiologists, this meant Atlas could be carrying raw materials that resemble the seeds of life. If such compounds are common in wandering objects, then the recipe for biology may not be unique to Earth, but spread across the galaxy. The idea touches on the panspermia theory, the possibility that life's ingredients are scattered from one system to another through comets and asteroids. In this view, Atlas is not just a frozen rock, but a messenger delivering the chemical tools that could ignite biology when they land on a suitable world. It raises the question of whether Earth itself once received a similar gift in its early days. Did a visitor from far beyond the sun help spark the first steps toward life? Beyond life's origins, the chemical diversity of Atlas also provides a direct test for planetary science. Comparing its makeup with solar system comets allows scientists to separate what is universal from what is local. If similarities exist, it suggests a shared galactic chemistry, while differences point to unique histories written into each star system. Either way, the results expand our view of how planets and life-bearing worlds might form in the wider cosmos. The findings from Webb's spectrograph turned 3I/Atlas into more than just an astronomical curiosity. They transformed it into a living laboratory, a frozen archive of another star's past delivered to our doorstep. But what about the size and survival of this strange hybrid? How could such a massive body endure billions of years in interstellar exile and still arrive almost intact? One of the most shocking revelations about 3I/Atlas is its size. Unlike the thin, cigar-shaped Oumuamua or the modest Borisov, Atlas measures several kilometers across. Some estimates even suggest it could be as wide as Manhattan, making it the largest interstellar visitor ever detected. For scientists, this is not just a number, it is a clue to how powerful forces must have acted on the object to eject it from its home system without breaking it apart. The surface also tells a story of survival. Images from Webb show bright reflective patches mixed with dark scars, giving Atlas the look of a patchwork quilt stitched together by cosmic violence. Each section may represent different regions of its birth system, fused into one body through collisions and accretions. This strange mix of ice and rock suggests Atlas is neither a typical comet nor a simple asteroid, but a hybrid of both. That dual nature is why it behaves differently from anything we have seen before, carrying both the sparkle of volatile ices and the hardness of fractured stone. Even more fascinating is how the object spins. Unlike the steady rotation of many solar system comets, Atlas tumbles in a chaotic way, as if thrown off balance by ancient impacts or bursts of escaping gas. This irregular motion hints at a dramatic past. Perhaps it was kicked out by the migration of giant planets in its home system, or maybe a close pass with another star sent it flying into interstellar exile. Whatever the cause, the fact that it endured billions of years without being ground into dust proves how resilient such bodies can be. The endurance of Atlas matters for more than astronomy. If kilometer-scale hybrids can survive journeys across the galaxy, then interstellar space may be crowded with similar wanderers. Each one could carry frozen archives of chemistry, geology, and history from faraway stars. This means that our galaxy is not just full of stars and planets, but also of silent travelers linking systems in ways we are only beginning to grasp. The idea that Atlas lived through countless stellar encounters and cosmic storms before reaching us makes it more than a simple object. It is a witness to galactic history, a relic that shows how matter can move across unimaginable distances and still remain whole. But if every interstellar traveler carries its own unique story, what do the first three, Oumuamua, Borisov, and Atlas, tell us when we compare them side by side? The story of interstellar objects began only a few years ago, yet each one has forced scientists to rethink what is possible. In 2017, Oumuamua appeared first, racing through the solar system with a shape unlike anything we had ever seen. It was long and thin, almost like a giant needle of rock, and it showed no coma, no tail, nothing that made it look like a normal comet. Because of that, some experts, including Harvard's Avi Loeb, wondered if it could be artificial. The mystery of Oumuamua has never been fully solved, leaving it as one of the strangest cosmic visitors in modern times. Only 2 years later, in 2019, another body arrived, but this time it behaved much more like something familiar. 2I/Borisov looked and acted like a classic comet, complete with a bright coma and tail stretching across the sky. It offered a clearer window into how icy bodies from another star might look, and its chemistry was easier to measure than Oumuamua's. Still, even Borisov carried surprises, since its gas content hinted at conditions different from what we see in most solar system comets. This showed that even a normal visitor could expand our picture of how planetary systems form. Then came Atlas in 2025, the largest and most complex of the three. Unlike the strange simplicity of Oumuamua or the textbook behavior of Borisov, Atlas showed a hybrid personality. It carried the icy glimmer of a comet and the scarred surface of an asteroid, making it a puzzle that refused to fit into any single category. Its sheer size, measured in kilometers, proved that entire bodies can survive violent ejections from their home systems and still reach us intact. That discovery alone has reshaped models of how planets and stars interact over billions of years. Together, these three visitors highlight the vast diversity of interstellar travelers. No two look alike, no two behave the same, and no two tell the same story. They remind us that the Milky Way is full of systems playing out different dramas, sometimes calm, sometimes chaotic, always sending fragments into the dark. With only 3 examples, we already see variety beyond imagination, which means that the next object may bring yet another surprise. If the first 3 visitors have already forced us to rethink so much, what will we discover when we finally trace Atlas back to its true birthplace in the galaxy? Every scar on Atlas' body carries a story, and those stories reach far beyond our solar system. When astronomers traced its hyperbolic path backward, they realized it likely came from the thick disk of the Milky Way. This region is older than our own thin disk, where the Sun and Earth were born, which makes Atlas something like a time traveler from a forgotten age. Its estimated age of 7 billion years places it almost 3 billion years ahead of our solar system's timeline, meaning it was already ancient when the first planets here were forming. This enormous span of time matters because it suggests Atlas has crossed environments that no spacecraft from Earth could ever reach. It has likely drifted through dense molecular clouds, skimmed past glowing nebulae, and endured the shock waves of supernova explosions. Each encounter left chemical traces frozen in its ices and etched into its rocky surface, turning Atlas into a living archive of galactic history. To study it is to read a diary written not by humans, but by the galaxy itself. The mystery of its expulsion is also part of its story. For an object this large to be thrown out of its native system, something powerful had to happen. Some scientists believe it may have been flung out by a giant planet moving inward, disturbing outer belts of ice and rock. Others argue that a close pass by a neighboring star could have shifted orbits violently enough to eject Atlas into interstellar space. Whatever the trigger was, the fact that it survived intact tells us how violent and chaotic planetary birthplaces can be. Atlas also challenges the idea that our solar system is unique. If this object was formed around a star billions of years older than our Sun, then its chemistry might reveal what kinds of worlds were possible long before Earth existed. Some compounds on Atlas do not match the profile of our local comets, hinting that different recipes for planet building were used in other parts of the galaxy. This could mean that habitable worlds, and even the seeds of life, may have been forming much earlier than we thought. The age, origin, and survival of Atlas make it more than just a comet or asteroid. It is a survivor from an era that predates our solar cradle, a messenger carrying the bloodline of stars older than the Sun itself. But if Atlas is a survivor, then what message does it bring, and why does it matter for us today? For astronomers, Atlas is not only a frozen body drifting through the dark, but a messenger carrying lessons across billions of years. Its chemistry proves that volatile ices and complex molecules can survive unimaginable journeys, which means that the galaxy is constantly exchanging building blocks between systems. This forces us to rethink planet formation because it shows that ingredients for worlds and even life itself are not locked within one star's domain, but can travel freely across interstellar space. The discovery also strengthens one of the most daring scientific ideas: panspermia. If bodies like Atlas wander through the galaxy carrying water, carbon compounds, and other precursors of biology, then habitable planets may receive them like gifts from afar. On Earth, similar deliveries could have seeded the conditions for life to begin, suggesting that our story may be part of a much larger chain. This is no longer just speculation, but a possibility supported by data. Since Webb detected unusual organics on Atlas that do not match the profile of solar system comets. The object demonstrates that alien chemistry is real and that it can reach our neighborhood. Beyond science, Atlas challenges culture and imagination. To see an ancient body glide through our skies is to realize we are connected to stars that lived and died before the sun was born. It turns the galaxy from a distant stage into a living network, where fragments of long-lost systems still pass us by. The image of Atlas glowing against the stars reminds us that humanity is not standing alone in the universe, but is part of a story that began billions of years ago and will continue long after we are gone. For the future, Atlas is a warning and an opportunity. We need stronger networks to detect such objects early, because each one offers a fleeting chance to learn about the wider cosmos. There are already calls for missions that could one day intercept or even capture material from an interstellar traveler. If that day comes, we may finally hold in our hands the proof that life's ingredients are scattered across the galaxy, waiting to be discovered. Atlas has given us a message written in ice, rock, and light. The question is whether we are ready to read it fully. And if more travelers are on their way, what truths about the universe will they reveal when they finally reach us? Atlas is more than a comet. It is proof that interstellar space is not empty, but full of ancient messengers. It showed us a body larger than any visitor before, rich in ices, scarred by impacts, and carrying molecules never seen in our solar system. This single object confirmed that the galaxy can move the building blocks of life across unimaginable distances, connecting distant stars to our own world. But if one visitor can teach us this much, what secrets are hidden in the countless others still drifting unseen? Stay with us, because the next discovery could change everything we think we know about the universe.